Okay, this video is to help you with the variables on both sides problems. Okay, I want to go over tip 3. And keep in mind, when we first did these problems, we just used tiles. So when I show this problem using inverse operations, I'll try to go back and talk about how we did it with tiles, and hopefully the tile part may help some of you understand the inverse operation way to solve it. Okay. So tip number 3, when you have negative x terms on both sides, add to get rid of the more negative x term. Okay, so this problem is negative 2x plus 3 is negative 4x plus 5. Okay, here's my tiles. Negative 2x plus 3 is equal to negative 4x plus 5. Okay, I would first focus on x's. And I would also want to get only positive x's alone on one side. So that's where my advice comes in here. Okay, if I have two negative x terms, get rid of the one you have more of, the more negative. Okay, negative 4x is more negative than negative 2x. Okay, I want to get rid of that negative 4x by adding 4 rectangles, green rectangles, to both sides. So if I can grab them all at the same time. Okay, and I'm going to do that as long as I add 4 positive x's to the other side. So I'm going to put, I guess I'll put them there. So what we're doing is we're adding 4x to the left, we're adding 4x to the right. Okay, before we talk about what we get, remember my step 3 always said, here's what you get. Let's take out the positive negative pairs. So let's take out this positive rectangle and this negative rectangle, and this positive rectangle and this negative rectangle, and all 4 of these positives and all 4 of those negatives. Okay, I'm going to drag these down to make it look better. Okay, and then what we have left is 2x plus 3 is equal to 5. Okay, so when we use tiles, we just looked at that. Okay, right, we just looked at the tiles. But let's look at another way to get 2x plus 3 is equal to 5. Look right here on your equation. You have negative 2x plus positive 4x. Well, you guys know that negative 2x plus positive 4x is 2x. And you still have plus 3 sitting there. 2x plus 3. Okay, on the right side, negative 4x plus positive 4x. Okay, those are like terms as well. So negative 4x plus positive 4x would be 0x, or 0. And so we're left with a positive 5. Okay, so we have 2x plus 3 is equal to 5. Okay, when we did tiles, I told you to focus on getting the green rectangles alone. Okay, to get these green rectangles alone, get rid of these 3 yellows. Okay, I can do that by subtracting 3 as long as I subtract 3 from the other side to keep everything balanced. So subtract 3, subtract 3. Okay, now think back before, well, let's not look at the tiles for a minute. If you have 2x plus 3 is equal to 5, you want to think inverse operations, okay, to get rid of the added 3, do the inverse of add 3, you would subtract 3. Okay, so we write minus 3 minus 3. And then, even though we can tell by looking at the tiles, the 2x balances with 2, okay, look right here on your equation method here. 3 minus 3 is 0. So on the left side, you're just left with 2x. On the right side, look what we have here. We have 5 minus 3. 5 minus 3 is 2. Okay, so that's another reason why we have 2x's is equal to 2. Okay, when we did the tiles, I said the last step is to divide stuff up. 1 for you, 1 for you. Okay, we divided each side up into 2 groups. See, there's 2 rows. And then we're left with knowing that each x equals 1. Okay, another way to think of it, we had 2x equals 2 here, over here on the right. Okay, 2 is multiplied to x. Okay, think inverse operations. To get rid of a multiplied number, we divide. So to get rid of that multiply 2, we divide by 2. And then when we do that, we end up with 2 divided by 2. 2 divided by 2 right here on the right, and 2 divided by 2 is 1. Okay, guys, hopefully this is helping. The big idea, though, is tip number 3. When you solve the problems in my slides, okay, to make the blanks work out, if you have negative x's on both sides, get rid of the more negative x term by adding it to both sides. Okay, guys, I wish you luck. You let me know if you have any questions at all, okay?